All right, we're back. One important element of an electric circle or an electric circuit or a source of energy, batteries or batteries, or sources of energy. And every battery has two terminals. It has a positive terminal. So if we look at these cells right here, these are all positive terminals, often identified with the bump, and the flat side are negative. These cells are all 1.5 volts. This cell here also has positive and negative, but that's 9 volt. So just imagine you have hills. These batteries are all hills that are not very tall, maybe only 1.5 meters of elevation change, if you want to use that analogy. This difference in potential or potential difference for this battery or voltage would be a lot larger than 1.5 volts. You might have a hill that's 9 meters tall. So when masses fall down tall hills, they'll have huge potential energy change. It means they're going to go, oh, I don't know, faster, have larger currents. More on that soon. And these offer small potential energy changes. So each battery has two terminals that are conductors. The terminals are used to connect the external circuit allowing the movement of charge. Batteries convert chemical energy into electrical energy, which, by the way, is mechanical in nature because charges are moving, just like mass is moving or roller coaster cars moving along a track. And they move because of what's called a potential difference. So this being a high potential and this being a low potential. A chemical reaction acts like an escalator, carrying charge up to the top of the hill. So just imagine you have a roller coaster and you have, let's use a different color. You have a hill and then you have it goes down through a loop and so on. So this is doing work going up the hill. This is like a battery. So work is done on charges to take them up and then they go down and they lose their energy. What goes up must come down. Click on the simulation in the presentation and play yourself with batteries. Check it out. Reviewing basic circuits. Electric circuits cannot have gaps because they are circles. If you have a gap, you won't have a movement of charge. The bulb has to be between the wire and the terminal or the battery. So again, you'll have a battery and then a continuous path of conductor, which you put a bulb in the middle of, and it burns. And a voltage or a battery is needed to make the bulb light, and the bulb lights regardless of where you put it in. And this is a wonderful video which is on YouTube, which uses the PhET simulation of two different types of electric circles, and you can observe all three elements of electric circuits: batteries, conductors, and loads or light bulbs, whichever you prefer to call them. And as you watch this video, observe what's going on in the circuit. Maybe make some notes in your presentation. You can compare it to your classmates. Tell me what the role of the battery is. Even though we just defined it, you'll be able to see that. Maybe looking at one battery versus two. How are these circuits in this similar and how are they different? Again, click on the link and check it out yourself. This is an informative video. It takes about 10 minutes to watch. Check it out. The battery pushes the current through the circle or the circuit. It acts like a pump pushing charge or moving charge. If we're pushing charge, you're causing what's called a current, and it's the circuit's energy source. Charges do not experience a force unless there's a difference in electric potential, unless you have a battery, otherwise they won't move. And batteries offer a potential difference between their terminals. What goes up must come down. It goes from a high potential to a low. So the positive is at a high voltage or a high potential, and the negative is at a low. How will voltage affect current? If we increase the voltage, you will increase the current. So one battery will cause a trickle of charge. Two batteries will cause a moderate flow of charge. Three batteries, when you put them in series, will cause a great flow of charge when you put them in line. Again, check out the video yourself. Take some time and watch it. And again, I want to remind you, this is just a preliminary video we're providing for you until the video gets uploaded to the NJCTL website. So